The mail just ran. I got these a little late, but in this box, look at this. It's plain, it's brown. B70 in the house. Let's get to it. This is B70, 32 gigs of VRAM, 250-ish watt power envelope. It's pretty awesome. A couple of things are worth grounding up front here, and that is Intel specifically positioned the Arc Pro B series around workstation graphics and AI inference. They launched the Pro B50 and B60 publicly at Computex on May 19th, 2025, almost a year ago. And their stack is open, like level 0, 1 API components, and now LLM scaler. Intel's public materials for the B series also emphasize XE2, XMX AI acceleration, larger VRAM pools, and local AI workflows. Not, you know, gaming stuff. We've been here for the B50, and then later the B60, and now the B70, the crown jewel of the Battlemage series. B70 is interesting not because of Intel's gaming story, or what they were planning with gaming, or workstation, because they may have genuinely built a 32 gig local AI card while not entirely having solved the software ecosystem problem. And again, 32 gigs of VRAM. It's roughly workstation card power, 250-ish watts. AI first messaging, and it's still suspiciously close to what enthusiasts were wanting in the Battlemage successor to the A770, and that's kind of what's in tension here. This might be the most interesting GPU that Intel has done in years, but facing the steepest of software uphill battles. This is Intel's Arc Pro B70. It's officially a workstation card, AI first, locally. Unironically, it's about as close as what we're going to get to Battlemage successor, or the Battlemage like gaming CPU. B70 is not a data center accelerator, and it's not really a normal gaming card, is what I'm getting at. It's Battlemage. Battlemage XE2 workstation GPU built around the same modern Arc graphics stack, but with the local AI stuff in mind, and features that local AI cares about. And this is squarely designed to take on AI inferencing workloads. So it's not cloud first, and it's not gaming. It's positioned to something else. If you're coming at this like this is Intel's RTX killer, you're asking the wrong question. The real question is whether this is the first Arc card where the memory configuration changes the conversation, because 32 gigs in this package at this price point, I think, is the story. It's not the peak tops. It's not ray tracing, it's not frame generation, it's not what Intel is doing with their software package with Xe over on the laptop side. Memory capacity, and to secondary, the bandwidth that you get here. And it's not a toy. It's pretty awesome. 30 gigs of VRAM lands here in a market where you can still pretend that you know, a normal person can get that, and also the power envelope is pretty normal. XMX is also another part you should care about. That's Intel's answer to Tensor hardware. Without that, this would just be a weird Pro GPU with too much memory. And with everything Intel is doing here, it sort of helps it become a serious local inferencing experiment. Intel won't call this the successor to the A770. That never was. I probably wouldn't either, but if you stare at the shape of this product, you know, sort of long enough, it starts to look like, well, I mean, not quite pure workstation, not quite gaming GPU, maybe a gaming GPU that got reassigned to a more defensible market. LLM scaler is something we got to talk about. Intel's own repo describes LLM scaler as an extension of VLLM, or a version of VLLM. Qwen 3.5 makes this interesting, because Qwen 3.5 talks about SG-Lang and needed to use nightly VLLM. So Intel has had an uphill battle to add support to Qwen 3.5 to LLM scaler, which is kind of a fork of VLLM. That is manifest of Intel's uphill battle in one sentence. The hardware is finally getting interesting at the exact moment the model ecosystem is moving too fast for lagging forks and compatibility layers. And so it's good to see that Intel, like literally right before this video, just by the skin of my teeth, they got it. CUDA is inertia. And if you look at ROCm has a clear identity now, but the ROCm experience is uneven depending on which version of RDNA hardware you have. Or if you have, you know, Strix Halo, that's also different. And on top of that, Intel is still asking power users to accept more friction in exchange for openness and better memory per dollar and experimentation. Whether or not that's a worthy trade-off is going to be up to the market. Intel is Intel's own worst enemy here. For this card to matter, works eventually is not good enough. It has to work when the model is hot, not after the hype cycle has moved on. And so this review is very different because I got Qwen 3.5 up and running. But let's dive into the performance benchmarks with that, because I have not won but 4. So with Qwen 3.5 27B, it is a dense model as a challenge. And this is a really impressive result. 369 tokens per second with a peak output of 550 tokens per second. Peak concurrent requests 50. So there's a bunch of requests running in parallel. Like one session on Qwen is not going to be 500 tokens per second. But massive parallelization on our 4 GPUs here with a 200,000 token context window. This is a pretty serious machine considering how good Qwen 3.5 27B dense is. It would be nice if the inter-token latency and the time per output token were a bit faster. There may be some room for optimization here, but for completely unoptimized, like I'm just running the thing, these are some really impressive results with these models. Now, for Intel's own benchmarks showing performance, they're maybe sandbagging just a little bit, and this could be VLLM performance that they're getting, they're squeezing out at the last minute. Intel's also partnered with VLLM. I just saw that announcement this morning. Literally, we had to edit the video before going live. We're doing experiments with 2 and 4 GPUs in the forum, so if you want the up-to-the-minute information on the live benchmarks or you want to see specific models, that's happening in the forum because I just got these, so probably do some follow-up videos later on this kind of thing. And the gaming benchmarks, it's not going to happen today because these cards hit retail tomorrow, I think, like B&H and places like that. And the driver, the Windows driver, doesn't work yet. So again, latest information is going to be in that forum thread. But that's okay, because at the end of the day here, this performance across 4 GPUs, I've got 128 gigs of VRAM. It costs less than Strix Halo, and this is way better performance for inference than Strix Halo. But that's all it does, because it's just GPUs. There's no networking, there's no anything. So it's a little bit of an apples to oranges comparison there, but if you just want a machine to do inferencing, there may be a there, software thing notwithstanding, but I do love to see the Intel VLLM partnership, and that is fantastic. So, oh, and in case you're wondering about SR-IOV, yeah, full support. Starting with the mature, it's starting to mature, except for B70. The B50 had the promise of 4 virtual functions. It's currently limited to 2, but previously it had more virtual functions than that. Intel, I see you, we need those virtual functions back. The B70 is the best of all worlds here though, because it supports a lot of virtual functions and it has a lot of VRAM. So yeah, if you're into SR-IOV, there's a lot of threads on the Level 1 Text forums. You should check that out. You go to the forum. This video is not about that, but we are going to cover a lot of SR-IOV stuff, and there's miles of SR-IOV content on the Level 1 forums. Intel's Arc B70 is one of the strangest GPUs in the market right now. Officially, it is kind of a workstation card, and it's built for local AI. And it's built on Battlemage's Xe2 architecture. Unofficially, it feels like the answer to a question enthusiasts have been asking since the Arc A770. What happens if Intel ships a high memory version of its modern graphics architecture in a sane power envelope? That's this. A lot of people have been asking for this. Well, here it is. Intel's pitch is simple. Open software, XMX acceleration, and enough VRAM to run serious local models without jumping straight to the data center. The dense Qwen 3.5 model is serious business, and you can run it on one of these, but with 2, it's really good. 32 gig and our hour of need. 600-ish gigabytes per second memory bandwidth also makes it interesting. So it's not the TOPS number, it's not ray tracing, it's not any of that really. It is the memory capacity, and the memory capacity being in the sweet spot for local inferencing. Once you start talking about 2 card setups, that's where it really starts to take off. The problem, and this is Intel's uphill battle, is and remains the software. Intel's LLM scaler is essentially an Intel optimized VLLM path, which is useful, but it also means the newest models show up in upstream VLLM or SGLang before the Intel stack is ready. That matters when things like Qwen 3.5 drops, and everybody wants to try it immediately. But the B70 story was not really there, even though the GPU hadn't released yet. Like if you got a B60, you're gonna wait. But Intel knows that, and so they were really pushing it up. So it's just gonna be a question of, can the software keep up? And really, it's can Intel's software team keep up? And we are just squeaking under the wire. Qwen 3.5 support, yeah, it's there. I'm sure that if I were trying to do this on an A770, I would be having a very bad time. So the surface area of what Intel has to support, at least right now, is less. So they have to maintain the inertia. And that's the interesting stuff. This is a first look at B70. If you want to follow the B70 content a little more closely, come hang out in the forum. forum.level1techs.com. I'm Wendell, Level 1. I'm signing out. You can find me in the forums and also with some follow-up content just as soon as I get all this put back together.